Hello everyone. Today we are going to do experiment on measurement of frequency, guide wavelength, power, and VSWR attenuator in a microwave test bench. The aim of this experiment is how to measure the wave guide length, operating frequency, power, attenuation, and VSWR of a reflex crystal. The components required for this experiment are: first one is microwave signal source, from where we will get a signals, and then microwave test bench and VSWR meter and a oscilloscope oscillator CRO. In microwave test bench, we have an attenuator and a tunable probe, and we have the MSR and VSR. Okay, now here the in main scale reading, MSR means main scale reading. Here there are from 6 to 19, whereas in VSR means vernier scale division. From it has from 0 to 10. Here first we have to find out the operating frequency. Okay, now how we can do the find out the operating frequency means first by changing the tuning voltage. Here you can see the in microwave signal source, there is a tunable voltage. Now you have to change this tunable voltage. By changing this one, you have to observe in oscilloscope. Okay, na CRO. You have to observe in oscilloscope so that it will reach the maximum point. Okay, na maximum voltage. It will reach the maximum voltage. I'm just changing the voltage. See now, see here, the you can observe there is a maximum voltage. Then after again, if you keep on varying the tuning voltage, it is reducing. See, it is reducing those voltage. You have to set for maximum voltage. Then for that one, you have to note down the frequency. Okay, now see here, there is a frequency of 8.284 gigahertz. Now you have find out the operating frequency, that is 8 point what we got 8.284. Here they got 8.93 gigahertz. We have to find out the operating wavelength. Okay, now the operating wavelength formula is lambda naught equals to c divided by f naught, where c stand for speed of light, that is 3 into 10 power of 8 meter per second, divided by what we got operating frequency. Now you got a certain value, that is operating wavelength. You have to find out the guide wavelength, that is lambda g. For finding out the lambda g wave guide length, the formula is lambda g divided by 2 equals to x2 minus x1, where lambda g equals to 2 multiplication of x2 minus x1. Here you can see 2. For x2 there is a formula, that is MSR plus VSR plus multiplication of LC, means in vernier scale. Now you can see the vernier scale. Here there is a main scale, that is MSR. Here there is a vernier scale, that is VSR, that is a least count. Okay, now from main scale there is a point, that is 0.1, that is a least count. Okay, now for least count there is a formula. MSR means main scale reading, VSR means vernier scale reading. The least count means there is a formula, that is smallest division on main scale. To find out the least count, smallest division on main scale, that is zero point 0.1, and total number of division on vernier scale. You have to take down for finding out the least count, that is 0.1 divided by 10, that is 0.01. To find out the x2 and x1, there is a formula. Now from the started line section, it should be a both maximum or both minimum. Okay, now here if you find out the x2, x2 means x2 should be both maximum here by changing a started line section, x2. Then x1 means it should be a maximum only, or it should be both minimum. From this minimum means it should be in oscilloscope, you will get both maximum and both minimum. Now you have to vary the started line section to find out the x2. See from oscilloscope, there is a maximum here. Okay, now you have to note down from this point. You have to note down the vernier scale. To find out the MSR here, from for zero line, which is the coincidence point from main scale, is 14.1. From here you can see there is a 14.1. To find out the VSR, from 0 to 10, which point is coinciding the main scale, you have to note down that point. See where it has been coinciding means fourth point, that is fourth point 4, you can take it as 4 here. VSR value as 4 and MSR value as 14.1. You have to substitute the value of MSR, VSR, and LC. For MSR, you got the 14.1. For VSR, you got 4. And for LC, there is 0.01. Then you have to substitute those values to get the X2. Similarly, you have to change the slotted line section to second maximum. See here, I'm just changing here so that you can observe in oscilloscope for second value of X1. See here, you got this point. At that point, repeat the what we got. Repeat what we found the as x2. Can a similar value for x1 also, MSR plus VSR plus in multiplication of LC. Same formula for x1 also. Then here you got some different value. Can then note down those values to find out the x1. By substituting those value, you got x2 and x1. Then you have to substitute those values to find out the lambda g. Okay, then then you get the guided wavelength. Okay, somewhat somewhere around you got like this. Now you have to find out the VSWR practical. That is VSWR means voltage standing wave ratio. That is the formula means V max minus V minimum. You have to changing the slotted wavelength here. You have to observe the oscilloscope. That is by setting this one maximum. See here V max. This is the V max. You have to note down the volts per division here. That is here there is one section means you have to sit here 1 2 3 2 point around 2.7 multiplication of 20 millivolts. This is the V max. That is the how many lines means there is 2.7 multiplication of 20 millivolts to get a V max. Similar way we have to find out the V minimum by changing the slotted section here. See just minimizing here. Now we can see it is near to 2.2 to 2.1 multiplication of 20 milliseconds to find out to get the V minimum. Okay, then you have to substitute the values to this formula to get a VSWR practical. That is how much you got for V maximum and how much you got for V minimum to get a VSRW. Now you have to find out the cutoff wavelength, that is lambda c. To get a cutoff wavelength, you already find out the wavelength of operating wavelength and guided wavelength. Substitute those values to get the lambda c here. Now you have already calculated the VSWR practical. If you want to find out the VSWR theoretical means by setting a slotted section to the maximum in oscilloscope, just you have to remove this probe and just you have to connect to the VSWR meter to get a theoretical VSWR value. Now we can see here SWR, there is a SWR. From that you have to find out it is pointed towards the 1.4. Can I just note down that VSRW meter? It should be matched to the practical value of VSWR value what you got in previous. To find out the power, here you should in dB it is pointed to 2.6 plus 40 range. Okay, na, 2.6 plus 40 to get a total power, that is power equals to 2.6 plus 40 dB. You will get a power. Next you have to find out the attenuation. For attenuation, just you have to remove this probe from VSWR meter and just you have to plug into this oscilloscope CRO. At that time, just you have to vary this attenuator for one rotation. You have to find out the attenuation, right? You have to just for first reading you have to rotate for one rotation. For second reading, just you took reference as 0 here and then you rotate one rotation again you got the same value 0. You should rotate in anti-clockwise direction so that you can observe here voltages. Here there is just adjust here, that is 1.2. Okay, 1.2 multiplication of 20 millivolts to get a value here. That is first reading. Similar way you have to find out the another readings, remaining readings, like same way. Just rotate one rotation and just observe the voltages in CRO, then calculate those things and substitute here to find out the attenuation.